Good afternoon, everyone. My name's Brian Horn. I'm with WISP Tracon from California in the US. Can everybody hear me okay at the back? Yep. Good. I'm going to be looking at conserving IPv4 addresses in routed environments. We're going to be looking at that and at OSPF. By a show of hands, can I get some idea of who's using OSPF at the moment? Well, let's do it the other way around. Who's not using OSPF? A few, okay. Because I'm going to go through the OSPF config as well. Who's using /32 routing for their network completely? Anybody out there? Not many, okay. So I'm associated with two companies, WISP Tracon, which is based in California. We do solutions training and consulting, focusing on MikroTik. And we're doing work in North America, Europe, and in Africa. And earlier this morning, you got to hear Anders Ahrens speaking. He's my partner in that business, where we do the consulting and the training. The other company that I own is Winters Broadband. It's a California-based ISP in the rural area, completely 100% rural customers. Oh, HowlRound. It was founded 14 years ago, and when we founded it, well, quite some time back, we got an ASN, and we got assigned a /22 address block. So we got those public addresses. And any of the CPEs and the customers that we have, we assign static IP addresses to them, public ones. This is becoming a problem in the US. I don't know about here, but we have a thing called DMCA. It's the Digital Millennium Copyright Act. And if somebody violates the copyright, the ISP is not held responsible if they're registered with DMCA, and we follow certain rules. And one of them is when you get a copyright infringement notice, and we get a few a week. These are where people go in and get into normally film libraries or music databases and download material that they illegally. So provided you know who did it, then what happens is you pass that warning message you got on from the lawyers to the end user, and they become responsible. You're not held responsible. But in the event you don't do that, and you doing source NAT, and you don't know who it really came from, you've got a major problem on your hands if it turns into a full-blown lawsuit. Basically what we do is give the people a warning. If they don't stop doing it, we terminate their service. We haven't had that yet. 1 or 2 warnings, people pretty quickly stop that. So if we look back 4 years ago, at that stage, the Winters Broadband was edge routed. By that I mean is that all the customer connections, the CPEs, were routed, but the actual backbone network was either bridged or switched. And any redundant links that were there were done with script controlled. And at that stage, were 40+ access point sites or tower sites and over 600 CPEs out in the network. It was dual homed. And the plan was to upgrade it to OSPF, and we were going to subnet it by site location. One of the things we did early on is we looked to see if we could get additional IPv4 addresses, and they were very difficult to get. Today in the US, under Aaron, they're impossible to get. There are some people who have hoarded them who will go. They didn't accurately fill in, let's say they didn't lie, but didn't accurately fill in their request initially, so they have more address space than they need, and some of them are trying to sell it at this stage. So the actual network looked a bit like this. It was also pretty complicated in that we kept, to try and keep track of IP addresses, what's used, how do you get to something. On the network diagrams, we would put these numbers that you see associated with it. So part of looking at how we were going to move forward is how do we make it easier? And in doing work for other companies and other ISPs, and looking how complicated they'd made OSPF, we also looked to see how we could make that a bit simpler. So when we looked at subnetting it, and subnetting it with the different sites that we had, this pointer's a bit weak, but on the left-hand side, you see the different sites, and then the colors show whether it was going to be 20/26, 27, or 28. The only problem is with that is you realize you run into problems very quickly. And we started trying to do it, and then we backed off because you get the loss of addresses, with the network address, the gateway, and the broadcast addresses. And then you've got a limited number of addresses in each subnet. So what happens when on a particular site you run out of IP addresses? On another site, you've got these IP addresses that are spare, but they're on different sites in the network. Your subnet's smaller, you've got a bigger problem. And then with the large number of tower sites that we had then, 40 plus, today it's a lot more, it was a case of if you put a new tower site in and you now want to switch the user across because you can get better service from a new tower, how do you go about doing that? That became a bit of a problem. So today, the network is dual-homed. It's got a 10 gigabit fiber feed and a 1 gig fiber feed. It's up to 56 access point sites today. All of the CPEs are now configured with /32 addresses, and there are no configuration issues. In fact, today we have spare addresses, whereas we were running out 4 years ago. We also have survey trucks that we use, which are actually, we've got 2 of them, which are news vans that we use by the news networks. If you're an ISP or a WISP, if you're going to get your hands on one, it'll be the best bet you can get. It's a very easy way of going out and determining what service you can provide somewhere. That truck puts up a 42-foot mast. It's got 2 and 4 gig equipment on the top. It can also act as an access point in emergencies. So those trucks can roam and connect anywhere in the network. The network architecture has changed to what you see here. And one of the things that I wanted to point out was that on the purple lines, you'll see there's very little information on them. Basically just a number and a dot. And I'll show you how we've managed to simplify the documentation and make it easy to know where to find if you want to get into a particular point in the network. So one of the things one needs to do, you need to do it is document your network. You need to know where things are when things go wrong. What we found with a lot of networks in the US is that they're small companies, 1 or 2 people know what it is. If the person goes sick, the things are not documented. If you want to sell your company, it's one of the due diligence things. And if you ever want to hire a consultant, you better have it documented first. If you don't, the consultant will go through and spend hours and hours charging you as he figures out what your network's doing. So if you take a look at that, one of the things is schematics. Visio is about the best thing we've found. Track your IP address assignment and come up with site designations that simplifies things. And I'll show you what I mean by that in a minute. And if you're going to make changes like we did to this, you need to document exactly what you have now and exactly where you're going to go. And you document it in advance because these changes on a live network have to be done early hours in the morning. They're normally done between 2 and 4 in the morning. It's the only downtime or when the minimum usage on the network. And you make a mistake then and you're out for a few hours. So what we did with the site naming is keep it simple. The airline codes, and all of you that have flown in, you'll notice IATA has a 6-digit code for your reference locator. What we use is 3. So we abbreviate a site name. MER stands for Merit, PLF's Plainfield, SVH Savannah Hills. So from that we know it. The other thing what we do is when you associate a number with a site, so example, MER is site 7. So that makes it simple then. Then if you have a link between sites, it's easy to name them. You don't have to get into complex names, just link SVH to MER. You know exactly where it's going. When we looked at the addresses, what we do there is take an IP block, for example, 10.0.0/16, And if you just use the last two octets and you use X for the site number, straight away you've got a lot of it sorted out for you. What we do then with the Y is that where we put it as it's routers. There's one router, it's .1. If there's a second router for some reason, it's .2. If it's an access point on the site, we go .10. If it's got an omni, or 11, 12, or 13 if it's a sector, and so on. So if you're trying to get to, for example, the power controller on site 7, it's going to be 7.40. If you want to get that same power controller on site 31, it's 31.40. You don't have to look it up. You don't have to have a drawing to get to that information. So what we did with the OSPF side is we said, okay, choose an IP subnet that you want to use for the links. So say you use 172, point is not much good, 172.16.x.y. With the X, we take the link number. And what we do to get a link number is you take the lowest number of the two sites. So in this case here, you've got site 6 and site 15. So we take link number 6. If for some reason you had another link out of site 6, and 6 is effectively used, you add 100. So that link would become 106. Then we got .1 and .2, because we're using /30. So it's very easy. The access point side is .1. The other side is .2. And then what we do on the drawings is we put the purple line in, and the side that's the access point side, or the .1 side, is where we put the dot. So from that schematic, we can very easily see, and we got all the information we know as to how to get into any link with a drawing that's really simple, like you saw earlier. If the OSPF, the cost is not 10, then what we do is we put 6/20, for example, where the cost is 20. What we've done in the same way to simplify if we use point-to-point wireless links on all of our networks, and we've got dozens of them. All we've done there is use exactly the same thing, but change the second octet to 17. So it's made it very easy to document and to know how to get into any link anywhere. And if you're overseas like I am at the moment, somebody gets in and asks you something, you can tell them on a phone quite easily. Sorry. Subscriber addresses are now under /32s, and we'll get into that. And that allows us virtually 99.9% utilization. We've only got the network address and the broadcast address that we're not using in the range. So we'll look now at just applying it to OSPF. And for those of you who haven't implemented OSPF, I'll show you how easy it is to implement it. One of the things that make sure you're running the same version of Router OS, and make sure you've upgraded the firmware. You won't believe the number of people that we help out where they upgrade the Router OS, but they don't realize they have to upgrade the firmware. Then things become unstable, and they don't know why. Make sure you've set the time and the SMTP client, so they're all on the same time zone. Check the log that it's there. One of the things that we've seen is that with the attacks, one of the things can be attacked as the NTP server. If you're putting that in your main router is then being attacked. What we do is that we have just a small 750. He's the NTP server for the network. So we take it out of the main router. We don't try to do it in the CCR. Set the router identity. And this is where you've got the site name. So if it was like MER, you can set the identity to MER. The other thing is, with regard to changing, when you change the name of the port, it's really a good idea to leave the Ether2 or Ether1 or whatever it is there. But make the name meaningful, because as you'll see as we go through the next few slides, if the name is meaningful, it makes sense very quickly when you log into a router. So what I'm going to go through is take a look at a simple network, and this is what we would, if we're configuring a 3-node network. So we've got 3 sites, which we're going to call 61, 62, and 63. And so the router ID on these, we've chosen that router IDs, we reserved 60 as a third octet for those. So we're going to make them 161, 162 and 163. And you'll see from the purple lines that the OSPF third octets in those addressing, we're going to use 61, 62, and 63. And 63 is going to be the backup link. So that one's going to have a cost of 20 to increase, actually to be, sorry, cost of 30, not thinking. So we'll now go through briefly configuring things based on that. So on router 61, what we do is create the loopback bridge, and we assign the router ID to that bridge. And we do the same thing for router 62 and 63. Oh, sorry. We create the bridge, and we assign the router ID that we got to the loopback bridge. When we come to the IP addresses on site 61, we're putting in the loopback address, the OSPF link addresses, then a gateway address for the /32. And I'm going to get back to that because we cheated this because it's actually a test network that's out there so we could gather data for the slides. And then the IP address, your upstream provider. So in this case, oops, I've got to press the laser. Where's the laser? So here's your loopback address. These are the addresses for the 61 link, we're .1. And so it's Ethernet 2 linked to site 62, 63.1, it's a /30 to site 3, and then this is the address for the link to the internet. In the same way, we add in the IP addresses for router 2 and router 3. And in these cases, we've got the loopback address, and then we've added in, for example, router 3, 62.2 and 63.2. And the naming here, it gives you the link to site 62, the link to site 61. So if you're going into any router on a site, if you've done the naming correctly and you've documented correctly, it's documented there in the router for you. You don't have to look things up. You will be surprised the number of people who will change the name and then they won't know what the Ethernet interface is. The worst I've seen is we had one client get hold of us and he gave us a drawing and he showed us all I said, we need a diagram. So he sent he didn't have one. So I said, well, just draw one up and then take a picture with your iPhone and send it to us. Send it to us. And the whole lot didn't make sense. Everything we tried doing just didn't work out. What they'd done, they drew it up, they drew the lines connecting the elements of the network together. And then so you got router, this is like an 850 or something. They went round and, port 2, 3, 4. And I said, but when we go in here, that's not what we're finding. I said, you shorts on this port number. I said, what do you mean? I said, well, you put port 2 there. He said, oh, no, when we finished doing the drawing, we just numbered around the edge, 1, 2, 3, 4, 5 going around. That doesn't really mean the port number. So here we got the instance that we have to configure. And so in this case, what we're doing is we're putting the router ID in that we gave. And for router 61, the main one that connects to the internet, that's where we're going to redistribute the default route, and then we would redistribute connected. And the big thing behind the /32 addressing is we're redistributing connected. So in the same way, when we go to router 62 and 63, the true remote ones, we've got the router ID is the 162, 163, and all we're doing in these cases is redistributing connected. With regard to the networks, if we look at the networks that we have there that we have to configure, we just have to configure in each case the 2 networks that we associate with. So router 1 is seeing 61 and 63, 2, 61 and 62, and 3, 62 and 63. If you haven't done OSPF before and you go through this step by step, you will end up with a working network. At this stage, you have a working network, and you can check it by going and looking at your interfaces, your neighbors, the routes that you have, and the link state updates that you're getting. So here we have the interfaces that we have there. When you configure it the way I configured it, these are dynamically configured. So you will see in each case there's a D. Delete it, it automatically goes back. But one of the things it didn't do is we don't have the cost equal to 30, because the default cost is 10, so we need to change that. So to change that, all we got to do is click on that interface, go to copy. To open it up, go to copy, change the cost, apply, and the interface will be replaced, in which case it becomes static, and it's done. One of the things you do at the end, once you've got everything configured and working, you would make the others static as well. But remember, when you do that, you have to do both ends of the link. OSPF neighbors, if you go in there, you should see your neighbors. So in each case, each of these you're seeing 2 neighbors, and you're seeing the number of state changes. As I say, this particular one we configured just for the to capture the screens for here, and only on site 3 did we connect a device. So you find the cursor's gone. The number of state changes in the bottom right-hand corner is a bit higher there. So on the routes on router 61, and I hope this is not a really bad eye chart. I know some of them, I've been sitting in the back and you can't see things. So I moved up to the front earlier. But basically what this is showing you in 61's route list, it's showing you the internet connection you have. It's showing you the loopback addresses that it sees and how to get to them. It's showing you the OSPF networks that are there. And it's showing you 1/32 device right at the bottom that we connected, which we gave a fictitious address. It's not one of ours. That ends in 6.32, and it's reachable through Ethernet 2 link, like site 62. It's actually on site 63. To implement the routing on the /32 routing, so this is the device to which the /32 CPE is attached. So what we do here is we configure there's a pointer's given out, but under the address part there, you see the last address is a 6.1. The network is 6.32. It's the reverse of what we're configuring in the client. So if we go to the client, so this is in a MikroTik client, we're giving an address of 6.32, 219.40.6.32, and the network is 6.1. In the actual router that connects to, and this, what typically we would have is connected to Ethernet 4, which is that bottom line, we would have an access point. The clients will be connected over wireless links. It's in bridge mode. The CPE is in router mode. And so in the CPE, we configure it as 6.32 as the address, 6.1 as the network. In the router that it connects to, we then configure it the opposite way around. So the network becomes 6.32. Also, in order to make this work, you've got to configure the port proxy ARP. Then what happens is what you've got once the device attaches, configure that, it attaches, then it gets redistributed as connected, and you see it come up in like the last line in the table there. If the CPE, the client, drops offline at the person's home or business, then of course it drops out of the table here. And of course, this works with other manufacturers' equipment as well. It is completely compatible. But on those, it'd be quite possible that you would have to configure it as the network mask would be all 255s. And certainly it works with laptops for testing. So other steps, if you get this far and you've got it all working, remember OSPF uses protocol 89. So you need to set up some rules in your firewall. The network type you can then use to optimize. What we did in the simple config here, it was broadcast. They could be NB, MA, point-to-point, or point-to-multipoint. And the BFD, bidirectional forwarding, can also be configured. It gives you faster link recovery, slightly faster. We've seen the time reduced from 10 to 8 seconds. And then also you can add security onto the links that are there. Typically what we do is in the ACLs on point-to-point links, things are locked out pretty well so nobody else can get into them anyway. But that's your next step in security. So if you're looking at doing any of this, really understand what you want to achieve, because if you're doing it early mornings or you're switching people over, you need to have a plan and steps to do it. The MTCRE training is really useful on it. If you need, there are lots of consultants worldwide that MikroTik has that can help. Document everything. I can't tell you the number of times when you're sitting there and making lots and lots of changes. It's really useful. The one nice thing with MikroTik is you can prototype the stuff very easily. Here you see just some of the small routers that we used to create the configuration that we used here. So you can create the configuration, test it, and then just implement it on your main routers. And just use the phased approach one step at a time, because if it gets screwed up somewhere, it's a little bit difficult to untangle it. I know that people have been taking pictures during the day of slides and that, but after the MikroTik does post the things on TikTube and on mum.mikrotik.com. And if for any reason you want a copy of the presentation from us, you're welcome to just drop us an email at consulting@wispracon.com, and we'll quite happily send you a copy there. Thanks very much, and if anybody's got any questions, I'd be happy to take them.
Thank you. Do we have any questions?
That's good. Well, thank you very much.
Thank you. So in a moment, we'll have our next presentation, ISP architecture, deploy virtualized public BGP routers with CHR for large-scale transit peering by Kevin Myers from USA.